This is an overview for AASHTOWare bridge design and rating software that touches upon several topics related to the application for beginners. This presentation will cover a brief history of AASHTOWare and how it is administered. It will also include a product overview, high-level product design, technology used through system information, major concepts, major components, major capabilities, and a few of the advantages of using AASHTOWare BrDR. This presents a history of AASHTOWare, which was developed around the early 1990s under the guidance of AASHTOWare. The groups of AASHTOWare applications are a result of funds invested by states of AASHTOWare and other state, local, and federal transportation departments. This software is owned by members of AASHTO. AASHTO is developed by collaboration of AASHTO member agencies through knowledge sharing and reviewed by the AASHTO Task Action Group. The product is administered by AASHTO and managed by a task force consisting of members from different state DOTs. The product is verified by the end user, that is, the member agencies of AASHTO. The following are the current task force members of AASHTOWare BrDR. Todd Thompson from South Dakota Department of Transportation is the task force chairman, and Vinax Vinayagarmuthy from Caltrans. Mike Johnson from Idaho Transportation Department, Mark Bucci from Louisiana Department of Transportation and Development, and Jeff Ruby from Kansas Department of Transportation round out the task force. Judy Tarwater and Ryan Fragapane are the AASHTO project managers, and Tom Sad is the FHWA liaison. One component of AASHTOWare BrDR is AASHTOWare BrR, which performs bridge load ratings. Its purpose is to determine the ability of the bridge to carry a specific vehicle, and to do that, we calculate a rating factor. The rating factor is calculated at multiple locations along the bridge by computing structural capacity and dead and live load force effects at each location. The structural capacity minus the dead load force effect is the available capacity at that location to carry the vehicular traffic. The rating factor is computed as the available capacity divided by the live load force effect. A rating factor greater than or equal to 1 is good, and a rating factor less than 1 is not good. This slide shows the state, local, and federal agencies along with consultants who are current licensees of AASHTOWare BrR software. The other component of AASHTOWare BrR is AASHTOWare BrD, which performs bridge design and rating reviews based on the load and resistance factor design. The purpose of the design review is to check if the design is adequate for the design vehicle. AASHTOWare BrD calculates the design ratio for each location based on the structural capacity divided by the cumulative demand of dead load and vehicular live load. A design ratio greater than or equal to 1 is good, meaning it passes the AASHTO LRFD specification checking. This slide shows the state, local, and federal agencies along with consultants who are current licensees for AASHTOWare BrD software. This slide shows a representation of the general architecture of the system. In the center is the user interface where the user enters data describing the bridge. The data that a user enters is stored in a database, which is either Oracle or Microsoft SQL server. The database is designed to hold a three-dimensional description of a bridge. Having three-dimensional data entry allows the data to be used by multiple analysis engines and multiple versions of the specifications without needing to change any input. On the left-hand side are the AASHTO engines delivered with the software, which are LRFR, LFR, ASR, and LRFD analysis engines. Third-party engines such as BRASS and LARS, for example, are also supported. The results generated by the analysis engines are viewable within the user interface. This slide outlines the analysis process in the software. In the first step, the user input represents the physical model of the bridge with dimensions and material properties. Then the user launches an analysis which generates a mathematical finite element model of the bridge from the physical model. The finite element engine processes the finite element model and determines the displacements and actions such as moment and shear acting on the structure. For vehicular loads, influence lines for 2D analysis and influence surfaces for 3D analysis are loaded to determine the live load actions on the structure. The next step is spec checking, which uses the physical model to calculate the capacity at each requested location to determine either the rating factor or the design ratio based on the analysis request. Reports are generated based on each of the analysis and reports requested through analysis. The development cycle for new features in the software starts with task force approval and requirement gathering. Design documents such as UI mockups and flowcharts are then created. The task force and beta tag, which is a technical adversary group composed of state agency employees who use the software, reviews and approves the design documents. Software development then starts, and alpha tested using agile software development methodology. Alpha testing is performed by engineers with bridge load rating and design experience. The software is then tested by the beta tag. After all features have been alpha and beta tested and the beta tag approves the acceptance build, a new version of the software is finally released. AASHTOWare BrDR supports the Microsoft SQL Server and Oracle Relational Databases. The language used for development is C# with .NET Framework Platform. All data entered by the user is stored in database tables. The system contains more than 1,000 windows, more than 800 database tables, and more than 10 million lines of code. Now we will discuss the 4 major components of the software, which includes the Bridge Explorer, the Library Explorer, the Configuration Browser, and the Bridge Workspace. The Bridge Explorer is designed like the Windows File Explorer, with files shown on the left-hand side and bridge files on the right. The bridges are organized as a list by their bridge IDs, which can be subdivided into different folders. There is a search feature to find bridges based on a few identifying criteria. A group of bridges can be rated from the Bridge Explorer, or a routing file can be used to rate a group of bridges satisfying a certain criteria. A group of bridges satisfying a criterion can also be moved to a folder and rated from there. The window also provides Bridge Exchange feature and Check-in, Check-out feature for bridge models, for a scenario of multiple engineers with the same bridge model on the same database. The Library Explorer contains a library of items to be used in a bridge model for analysis. The library is delivered with items found in various standards, such as the AASHTO specification and ASTM specifications. Agencies are also able to add their own items to the library. Beam shapes contain steel shapes from the AISC manual and pre-stressed beam shapes from the PCI Design Handbook. The library also contains materials from the AASHTO standards and vehicles based on the LRFD design specifications and the Manual for Bridge Evaluation. The library also contains load and resistance factors from the LRFD design specification and the Manual for Bridge Evaluation. The configuration browser is mainly used for administrators of the software. Administrators can add users, set privileges, and enter parameters such as names of counties and districts. Administrators can also enter agency-related system defaults, like the default specification to use and tolerances. The Bridge Workspace is where all the work is done related to defining components of a bridge, defining the bridge geometry, and analyzing a bridge model. As mentioned before, the 3-dimensional model of the bridge can be entered. In this system definition model, all the loads acting on each member can be computed by the software. The software also computes the live load distribution factors for each member based on the relative location of the member. For the few types of bridge geometries not supported by the software, a line definition model can be used. In a line definition model, the user is responsible for entering the dead loads and the live load distribution factors. Now we will talk about some of the capabilities of the software. The software can compute LRFD design review or design, capacity computation using LRFD and rating with LRFR, capacity computations with LFD and rating with LFR, and capacity computations using ASD and rating with ASR. A member alternative analysis setting allows the user to specify a load rating type, such as LRFR, LFR, or ASR for each member alternative, and then launch an analysis where some members of the bridge are rated by one method, such as LRFR, and other members of the bridge are rated by another method, such as LFR. In terms of steel bridge types, BrDR supports rolled shapes, welded plate girders, and built-up I-shapes. For prestressed concrete beam types, BrDR supports prestressed I-beams, box beams with both rectangular and circular voids, multi-stem T and U-beam shapes. For reinforced concrete beam types, BrDR supports T, I, and slab beams. From version 7.1 onwards, it will also support a reinforced concrete advanced shape, which can either be reinforced concrete or post-tensioned. BrDR also supports reinforced concrete slab systems with solid and voided sections. A user-defined slab section can also be determined for evaluation, for which the live load distribution factor and the load will be proportioned. Slab integral with pier is also supported for analysis. Reinforced concrete multi-cell box is supported for LRFD, LRFR, and LFR. Either web lines or the full box can be analyzed. Multi-cell box also supports analysis with integral pier. Post-tension multi-cell box is also supported for full box along with web lines evaluation. Post-tensioned multi-cell box also supports integral with pier analysis. Analysis of floor system bridges is also supported for LRFR, LFR, and ASR analysis. The following floor system configurations are supported in the form of system or line superstructure definition, girder floor beam stringer, truss floor beam stringer, girder floor beam, truss floor beam, and floor beam stringer. Floor truss in floor system is also supported for LFR only. Steel truss bridges can also be evaluated for LRFR and LFR. The following types of steel trusses are supported: continuous span, suspended span, truss with countermembers, deck truss, and through truss. Sawn timber beam analysis is supported, including timber deck rating. This analysis is only supported for ASR. The timber analysis is performed using the third-party engine Madero. Reinforced concrete box culverts are supported as well for LRFD, LRFR, and LFR analysis. Configurations with sloping fill multiple cells are supported. The software also supports culverts with or without bottom slabs and haunches. The BrD application also supports pier design review analysis for multi-column frame piers, solid shaft piers, pile bent piers, and wall piers. Foundation types include spread, pile, and single drilled shaft foundations. Foundations are not added to the FE model but are evaluated for specification checking. Nonlinear analysis is performed for single drill shaft foundations. The software provides graphics to validate entered bridge models as seen here. The top left is the structural typical section, followed by the member elevation on the top right, the framing plan on the bottom left, and a multi-column frame pier on the bottom right corner. There are other additional schematics available that are not shown here. This slide shows the analysis plots available for one-dimensional and three-dimensional analysis. Also, the software generates the mesh for the finite element model automatically. Transverse live load analyses are performed to position lanes and trucks inside those lanes within the travelway, which is then used for influence surface loading. Each point analyzed by the software has actions which are reported in the form of tabular results as shown. Detailed specification checking for each point of interest for all analysis types is also available as shown on the right-hand side. Now we will go over the advantages of using AASHTOWare BrDR. Design review and load ratings can be performed using one user interface and one set of data, which can improve productivity of the engineers through the lifecycle of the bridge model. Bridge models are stored in the relational database, which provides data integrity and can be backed up occasionally. The administration of an agency's bridge inventory becomes simplified through one product. The software allows 3D descriptions of bridge models, which can be used with multi-versions of AASHTO specifications, analysis methods, or analysis engines. This also provides the flexibility to compare analysis results between the line girder and 3D analysis. Research can be performed using the software to evaluate proposed changes to the AASHTO specification by making changes and comparing results before production use. Licensing agencies can request new features by using service units. Users can vote on the top 10 features they would like to include on the software. There is a technical advisory group, TAG, which advises and reviews on how the feature should be implemented in the software. Third-party developers can develop their own analysis engine by taking advantage of the Engine API. Third-party developers can develop plugins using Domain API to change bridge data with their software. Third-party developers or a permit routing analysis can use the Analysis API to run analyses using the AASHTO engines without opening the user interface. Thank you for your interest in AASHTOWare bridge design and rating. We hope to hear your feedback soon.